Welcome. This is 5.9 task. This is the median proof here. And before we get into this, let's talk about review what similar triangles are. Similar triangles would be triangles that, let's say you have one triangle with like ACB, and the angles on ACB might look something like this. Let's say they're all different. Well, that triangle is similar to another triangle, which is the larger one. Okay, because that larger one also has the same three angles. So we can say that they're similar. And when we say that, we can say that that the ratios are congruent, like the distance of CB divided by ED is the same thing as, so this side to this side is the same thing as, say, this side, AB, to the whole thing, the bigger one, which is AD. So we can use those ideas with a similar triangle in this particular proof. All right, let me clean this up a little bit. And let's look at what we're doing here. So the question is, if you have a ray right here, this is DF. So this ray that I'm doing in blue, right here, if I already have two medians and that ray intersects with P, is it also a median? So that's what we're trying to figure out. Is this a median? Now, a median, if you remember, is something that is going to bisect the opposite side. So in this triangle, AB is the opposite side, Z is the vertex. If it's the median, that means that those two segments would be congruent. All right. We can actually show that if we show that this is a parallelogram, because one of the properties of the parallelogram is that the diagonals bisect each other. So if it's a parallelogram, then these two have to be congruent. So really what we're trying to do is show it's a parallelogram. Parallelograms means opposite sides are parallel. So they've given us some information here that we can use. Take this out here. They've given us the fact that NA and MB are medians. So if NA is a median, that means that those sides are congruent. And if MB is a median, that means that those sides are congruent. Okay, but what we're going to do, oh, the other thing is AP and GB are, so here's AP. And here is GB. They're saying that the given is that those are parallel. Okay. Now, what we're trying to prove is that CF is a median. And if we can actually show that CMP and CAG are similar. So this triangle right here is similar to the larger one here, just like the example we did earlier. If that's true, we have some corresponding angles, and we can show, let me take that off, we can show with those corresponding angles that, let me put this back on here, this parallelogram. With those corresponding angles, we can now say that the other sides are parallel because of these corresponding angles. So if the other sides are parallel, that means that APBC is a parallelogram. Opposite sides are parallel. And so therefore AM is congruent to MB. So AM right here is congruent to MB, and that's the idea that a parallelogram has bisecting diagonals, and that's what we were trying to prove in the first place, that it's a median and that those two are